Elisa. Elisa is a PhD student in the Irish and Global Security Book in Eindhoven, and today she will be talking about the anonymous payment system. So, Elisa,
thank you for the introduction. Just one note before starting, the slides are available on the following slide, and also you can scan the QR code. Some of them are interactive. There are some web page you can browse yourself and just click hyperlinks. So I advise you to just see them yourself. Okay, let's talk about Taler. If you never heard of it, Taler is a digital payment system. Since it's a digital payment system, I would like to start answering the question, why Taler? We have thousands of digital payment systems right now available, and so why we should use Taler instead of all the other ones? Let's start with the most classic ones, the one who's everyday, like MasterCard, Visa, even like the European alternative right now, which is Wiro, or whatever you call it. And the thing is, these are really efficient, really useful for everyday payments. But the thing is, the companies can see your transaction, they can see your payment, they can actually trace whatever you're spending as an everyday user. And this brings some like traceability or profiling, but also in general sensitive data exposure. We are an event called security in times of surveillance, so it's clear where these properties are not desirable. Actually, someone has considered this problem many years ago, in 2008, and they invented this. And the thing is that, yes, this is actually a good way to avoid company overseeing whatever we're doing with our payments. But the thing is that with this payment system, a lot of other cryptocurrencies came along. And you have a lot of cryptocurrencies for all the different flavors you want. You have stablecoins, you have central bank digital cryptocurrencies, but also you have cryptocurrencies that guarantees complete anonymity and not just pseudonymity like Bitcoin. So you can actually have whatever you want, the floor is yours. But did we solve the problem? Was it so easy at the end? And the answer is really complex. From one side, they solve a lot of these problems. From the other side, they also introduce other problems. I would like to bring your attention to this website, which is called Web3 is Going Just Great from Molly White. You can browse yourself and see all the articles they're reporting here. And the thing is, these Web3 cryptocurrencies, all this stuff, are bringing an enormous economical and ecological risks. If you think about proof of work cryptocurrencies, for example. And on top of all of this, we also have these cryptocurrencies for design. They don't inherently avoid frauds, blackmailing, generally deregulation, or money laundering. What if we want actually to avoid these things because we're actually we want maybe to bring these properties? And the thing is, we live in a real world, and unfortunately, real world has rules. In our case, rules are called banking regulations. What economic literature came up with is something called asymmetric privacy. Asymmetric because from one side, you have the customer, which is anonymous. The customer is protected. Transactions are not revealed, can do whatever he wants, and is totally protected. From the other side, you have the merchants. And the merchant has to declare the money he receives. Cannot be anonymous with the system. The merchant is exposed to the system. And this is exactly what Taler wants to achieve. Asymmetric privacy, and in particular, free properties. The first one is obviously anonymity of the customer. The second one is enable taxation for the merchants because you identify them. And the third one is anti-money laundering. On top of all of this, Taler wants to be open source and available to everyone. They can take it, modify, and probe secure. So, all these properties make Taler ideal to be used as a digital currency. Think about the digital euro. This is exactly what we want to achieve. But not only, the Taler protocol is actually bringing us some nice use cases. The protocol itself can be used for other use cases. For example, vouchers, loyalty cards, all of these preserving anonymity of the customer, online age verification, but also streaming service subscriptions. All of this can achieve just adapting the protocol for our everyday use. And this is not just a dream, it's deployed in real world. For now, only Switzerland, but we're trying to expand to other countries. And you can actually see where you can pay with the Taler now, right now. If you want to see, if you are in Switzerland, you have a Swiss number, and you pass by bill, you can just buy a kebab with Taler, if you want to try. Okay, Taler is what is called an electronic cash system. Why it's called electronic cash? It's because it works exactly like physical cash, but digital version. With cash, for example, I go to an ATM, I withdraw some cash, I go to a merchant, whatever, I pay for something, give them some bills, whatever. They also give me change back if the bill is not precise. And with the remaining amount of money, I can just go back to the ATM and deposit that money. And this is exactly how cash works, but digital version. This is a rough overview of how it works. Things are not really working like this, but it's just to give you an intuition of what's happening in the system. First of all, we have two actors, the customer and the customer. The customer has some money near this bank, and imagine this customer now wants to enter the Taler ecosystem. First of all, we need to introduce a third agent, which is the exchange. The exchange is it's called Digital Payment Service Provider. I will explain better what's his role. But basically, the customer first creates a reserve near the exchange and transfers some money to the reserve. Now, the exchange is keeping in escrow some money from the customer, and this is really important role of the exchange. We don't want exchange to deny service or anything else, or running away with customer money. We introduce some authority that actually control exchange behavior. Now, we have the customer that wants to withdraw some money. The customer has a wallet, and they initiate the withdraw protocol, which is actually a way to withdraw money. So the exchange, with some cryptographic magic, will anonymize coins, and the customer can withdraw these anonymized coins, and the exchange does not see these coins, basically. Now, trust me, it works like this. Later, I will explain how cryptographically it works. Okay, so this is called the withdraw protocol. Now, the customer has some money in the wallet, and he wants to pay a merchant. So, what he does is initiating an anonymous payment process. We're using an anonymous channel between the customer and the merchant. The dotted lines represent anonymous channel, and this is an anonymous payment. We're just transferring some money to the merchant. Please note that this is not exactly how it works. We're not giving money, giving coins to the merchant. But before this, when we pay someone else, we could actually have partially spent the coin, the money, and so the customer can actually, after this called spend protocol, can actually ask for change for the partially spent coin. And this is called refresh protocol. Okay, the merchant now has some money. But first of all, he has to deposit his money. The core part of Taler is that the merchant, once he receives money, he cannot spend money near someone else. The thing is that to get really that money, he has to deposit them to the exchange. And this is where the only for the customer anonymous part comes in. This is where the asymmetric privacy comes in. The merchant cannot spend again that money. He has to deposit them to the exchange. And this is like declaring the merchant, oh, I receive this money to the exchange. And the exchange, for example, can tax the merchant now. Okay, after we deposit coin in the deposit protocol, now the exchange convert this money, real money, and sends them to the merchant bank. And merchant has the money. Okay, a few things about this. As you can see, first of all, this system is online because you need to prevent double spending. And second, it's centralized. The exchange is at the center of the system. It's not a decentralized system like some cryptocurrencies. Okay, so now a bit of crypto. I promise it won't be so hard. You just need to know a bit about digital signatures, but I won't be too deep about some concepts. What we use in Ecash is something called blind signatures. I will try to explain to you this object, mathematical object, like the first time it was introduced in literature. And this is introduced with this concept of carbon copy paper. I don't know if you know what's carbon copy paper, but basically it's this special kind of paper where you can just write something on the paper, and if you have some paper underneath, whatever you write on the paper on top, it gets transferred on the paper underneath. And imagine you build an envelope made of this special carbon copy paper. Now, inside this envelope, the customer in this case insert this kind of certificate. Imagine it's like a check, if you know what a check is. And it's saying that this check is, for example, having a serial number, and it's saying that it's worth $10 in this case. And the thing is, how would we certify that this thing is actually called, it's actually worth $10? We blind it. So we just close the envelope. This process is called blinding, and we send it to the bank. Now, the bank is not seeing anything because the envelope is closed, but can sign the envelope with a special pen, a $10 pen, with their signature, which is a digital signature, and subtract $10 from the user account. Now, the envelope is signed, and the bank never saw the content of this envelope, and sends the envelope back to the customer. The customer now has the envelope, open it, and the check underneath has the digital signature transferred on the paper underneath. So now we can actually validly use this check, which is signed by the bank, but the bank never saw the content of the envelope. And this is why it's called blind. Now, this is the basic. Now let's go how actually your coins are structured in Taler, which is kind of complex, but we will guide you through. First of all, let's imagine you have a customer and he wants to have this coin. First of all, a coin is not made in this case of the serial number, but is indeed made of a digital signature keeper. So you just have a secret key, which is in this case represented by a key, and a public key, which is represented by a lock. All this secret key will be represented by keys in this presentation, and all the public key were represented by a lock. Now, we have this nice coin with this keeper, but we want to assign some value to this coin. And this is not something that the customer can do alone. And this is where the exchange comes in. Okay, so how do we exchange assign value to this coin? These are where other digital signature keeper comes in, this time they're belonging to the exchange. But it's not just one pair of these. we can give multiple different values to the coin. For example, a coin can be worth $2, $3, $4, whatever. So we have numerous pairs of these here, each one for each value, and they're called denominations. So now, if I want a coin that's worth $2, I will go with the denomination corresponding to $2. In particular, what the customer can do is saying, okay, this is the public key of the corresponding value I want, and the exchange will sign the public key of the coin with the corresponding secret key. So basically here I have the same coin and the public key of the coin, which is signed by the exchange with the corresponding secret key of the value I want to give to this coin. Okay, but at this point, we have a problem, because if things would go like this, the exchange would see what you have in the coin, and sees the coin and sees the public key, and we don't want it. So in reality, these denominations are actually blind signature keepers. How do we put everything in practice? Same protocol, blind signatures, but during the withdrawal protocol. So how we actually withdraw coins in Taler. Let's imagine the customer has a $10 coin and wants actually to withdraw this coin from the exchange. The exchange possesses the corresponding secret key, which is worth $10. First of all, the customer creates a digital signature keeper for the coin, and he put in the structure the corresponding public key of the denomination. Now he creates an envelope, put the public key of the coin in the envelope, and outside of the envelope, put the denomination, the public key of the denomination. Now blinds the envelope, close the envelope, and send it back to the exchange. Now the exchange is saying outside, we have this thing by saying, I want a $10 coin. So the exchange just signs with the corresponding secret key this envelope and subtract $10 from the user account. Now the exchange sends the envelope back, the customer opens the envelope and sees its carbon copy paper, the signature has been transferred underneath, and we have the final coin. But the exchange in the process never saw the public key of the customer. So if the exchange later in the system sees this public key, does not know who customer is belonging to. Okay, so now we actually withdraw some money, and we see why we actually use this secret key and public key in the coin and not just serial number. So let's imagine we want to pay someone finally. Okay, let's imagine we have a merchant that's selling us a $5 t-shirt, and we are a customer with a $10 coin in our wallet. So now we don't want to transfer this coin to the merchant, but in Taler, we basically sign a contract with the secret key of the $10 coin. So we are not giving the coin with secret key, whatever, to the merchant, but we're just signing a special contract that alone cannot do anything. The merchant, to get the money, has to take the contract and deposit it to the exchange, and the exchange will send money to the merchant's bank. And this is where the non-transferability is coming from, the asymmetric privacy comes in. So it's basically a digital signature on a contract, not a transferability of a coin. Now that we paid $5 to a merchant, we have a partially stamped coin. We spend only $5 on this coin, so we actually want to be able to spend the remaining amount of the coin. And I think in Taler, we do the same as we do in real life. We ask for change. So, takeaways of this. The ownership of a coin is never transferred. Second takeaway, change is not so trivial as it looks. We must ensure two properties of change. First is anonymity. So spent coins and change must be unrelated. If I spend first €5 for a shirt and I want to spend the other, like with the change, the other $5 for a really expensive ice cream, I don't want someone observing the system correlating the two transactions with each other. And second property, I want to avoid money laundering. So the ownership of the change we obtain cannot be transferred. Like a coin cannot be transferred, I don't want the coin change to be transferred to someone else. Otherwise, it's invisible to the system, someone can receive money, cannot deposit, won't deposit them, and this is exactly what we intend with money laundering. So, what happens exactly if we implement naively this change in Taler? How would we do perform money laundering in Taler without other tweaks that we introduce later? Okay, first we have a user A who possesses this $10 coin, and they spend this money near a merchant, like before. Now we have a partially spent coin, and now imagine there is this user B who's selling this nice drone to declare money because he's doing illegal business and does not want to be seen into the system. So, A, just share the coin with B. B is not illegal in Taler. You can share a coin with your friend, with your partner, whatever. It's not like something illegal. The only thing you cannot do is transfer ownership. B is not transferring ownership. You're just sharing a coin. Now imagine it's user B to ask for change. The change now belongs to user B. We actually transferred ownership, and this is not something we want. So how do we fix this in Taler? Okay, let's imagine now user A, which is the owner of the initial coin, can run some routine and reobtain the same coin in some way, even if it was not the one who was changed for. And this is good because we're not transferring completely ownership of the coin to the other owner. The same owner of the first coin will be always the owner also of the change obtained later. So, to wrap up, change requirements, anonymity again, no one, but this time except the coin's owner, because you can reobtain the coin, can correlate spent coins and change. And the second, anti-money laundering, an owner of a coin can always reobtain change from their coins. So, I will show it again with the coin structure, but with a refresh protocol. As I showed before, the diagram, it's actually the diagram, something went wrong with the font, but the thing in the diagram, you have these get change dotted lines, which actually represent the refresh protocol. And this is an anonymous channel. The details of this refresh protocol are cryptographically really complex, so I won't explain in detail, but I want to show you with the coin structure what is the main idea of the refresh protocol. So imagine we're a user A and user B sharing a coin, and sharing a coin means that share everything of this coin. They share the keeper, they share the signature, they share this denomination on it. And the user B refresh this coin and obtain another coin. Now user A, in some way, runs a routine, which is called differently, depending on the case, but can reobtain the same coin using the structure. And again, the ownership of a coin can never be fully transferred. If I have the first coin, I will obtain always the second coin. Even if the second coin is refreshed again, is getting changed again, I will always be able to obtain the final coin. Okay, this was one of the main things I want to show you in Taler, but before concluding, I want to give you some sneak peek on what we are currently working on, because all the things I show you now is actually pre-quantum. So we actually want to have Taler transferred to post-quantum, and this is something what we're working on. And the problem with the Taler is that it's using not classic protocols. You can actually use drop-in post-quantum primitives. In particular, the refresh protocol relies on properties that are unique to classic crypto. So what we had to do was to redesign completely the refresh protocol such that it can be use the post-quantum primitives. And they're not just flying to the problem. Okay, so this is the end. There are some more resources you can browse and click on your phone if you have your slides on your phone. I'm over focused.
Okay, thanks, Lisa. I think we have some time for questions.
So for the reobtaining the coin mentioned, so essentially it's the exchange that will get information. It will not again get the money from the user take back. Is that correct?
I think I didn't understand.
So you say they reobtain a coin of $5 after they purchase that.
Yeah.
But that is going only communication to the exchange part and not to the customer's bank account. So they're not obtaining it from the bank account, but obtaining it from the exchange.
Yes, only in the diagram, Taler is happening only in the blue arrows. So the change and everything is running between the customer and the exchange. It's not using banks or anything else. Customer banks and the purchase bank are external actors from the system.
Thanks for the talk. Assuming that all the transactions in blue, you said, are performing well and stable, I'm wondering about the transaction costs and also the benefits of the exchange service as it works. And why was it as a centralized service more recently?
You're asking for the economical cost of the transactions. Right now, actually, Taler is operating at really low fees because it's a startup project, but it's not based on getting fees. It's much more like right now there are basically no fees. This is really encouraging also for merchants. And right now, this is something that actually this is a protocol. So. And it's open source. So whatever company wants to adopt it, right now we have, for example, Taler System SA or AG in Switzerland, can just take it and put in whatever transaction cost and all the business model they want. Also for scaling, like scaling the protocol, using hardware, cloud system and stuff, it's something that you can build up on the protocol. So GNU Taler is giving you a protocol, and whatever you want to build on top of that is something that banks and everyone else can do.
Okay. Is there a minimum number of users or volume of transactions that is required for anonymity?
Nice question. There is no minimum number, but the thing is, ideally, you need quite some people. Otherwise, if you're just one user in the system, it's really easy to do that. It's like withdrawing some money. And one good thing to notice is that it's advised to withdraw coins in bulk. Because you don't want to, for example, withdraw one money, like $1, and spend $1 because it's traceable. But you need to withdraw large amount of money and then large amount of coins and then spend them later in time during a large amount of time. Yeah.
Okay, so it's difficult to see that one user is too little, but do you have some recommendations or idea of how many users you actually need to talk to?
No, I honestly don't know. I don't think there is it was made an estimation of how many users, so because it's quite small right now, so it's but a country will be enough, like the current size of Visa MasterCard is not something that you can actually, I think that will be enough.
Hi, thank you for this very interesting talk. I was wondering, so it's clear that the exchange has a critical role in this security protocol. Would it be possible to change the protocol a little bit, or I should probably phrase it differently? Would offline transactions be possible in this system?
This is something actually, this is actually something that is kind of critical in Taler, because you need to be online, and this is also why the European Union is not on the same page as Taler, because, for example, they require the digital euro to be also able to perform offline transactions, and this is something that is not like possible in Taler, but this is some design choices that came after what you want from the system. And the thing is that you want for the system, in this case, to be online to prevent double spending. You can have some kind of disenchanting for double spending, but the real thing is it's an impossibility result. You cannot have double spending without being in this kind of system. So even like with some design of the digital euro, you still are not, even if you're having offline, but you're like giving up some security thing that we still want to maintain power.
Thanks for your talk. I wondered a couple of things, but just the main one that pops up is, if you think about this in traditional banking system, Visa and MasterCard, for example, are shutting out, say, people from the international criminal code or whatever. How might this compare in terms of privacy of using these debit cards, which are all over European banks? If we were to use this as a, say, hardware insurance strategy, does the exchange have the same amount of power Visa and MasterCard did? Does it have less? How does it compare? And it seems on its face from the top that it's significantly better. Hardware is reduced, what they see is a lot less. But the credit card can also be used offline. So I wonder how do you compare these things? Like, would you feel more comfortable as a using this rather than Visa or MasterCard, for example?
The thing is, this system is providing privacy, and it's not like the exchange has some power in the sense that it's having your money, but they cannot see your money or what's your, for example, secret keys and private key because privacy is. So the exchange is completely blind to the system. It's not available. It does not know what's customers happening, like who you are in the system. So the thing is that MasterCard is not anonymous. So they have power over customers, but here you have privacy, so it's completely different. Like if you want to pledge fees for like withdrawing money or whatever with the exchange, you can do it because Taler is profitable. It's not like a system that it's not like a business model. So yeah.
Thanks. Great time. Great work.
Thank you. So maybe we have time for one last question because we're already taking time off the hands. And the other questions can be taken offline.
Yes. Thank you for the compliment. That was the same thing I was interested in. Our existing protection for the binders of protection and risk, and how does the transition to the new system look like? We have to rebuild the system and somehow cooperate to transfer the risk.
I'm sorry, can you repeat?
Yes, so one is about the transition. So how do you get from as for the current system to the new system? You need for the old new system essentially to operate two separate entities. And the first question was, are the existing transactions at risk of the quantum computer?
You're asking if right now we're protecting against quantum transaction or?
Yes, so it's one about the knowledge of the existing system. Is that at risk with quantum computers?
Okay. Right now, the design of post-quantum is actually only on paper. and it's just design a protocol. So we're actually working on implementing this with in code or being deployed, but for now it's not still deployed. So right now if you use Taler, it's using still rebound version.
En je doet dus een moment in dat sense.
Yeah.
Okay, so let's thank Elisa.